All right, today we're going to be talking about trigonometry, take 2. Hopefully this video actually records. For some reason, I can't get the page to stretch out the whole screen. I've tried, so we're just going to have to look at it halfway. So deal with it. Okay, so trig. If you have a graphing calculator at home, please use it. If not, then please go to this website right up here to help you. We will need information on there, sine, cosine, and tangent buttons to help us. All right, so trigonometry is the study of right triangles. Okay, we use it to find missing side lengths and missing angle measures when any of our other methods do not work. For example, if it's a right triangle and we have two sides, if you're trying to find the third side length, you of course can use your Pythagorean theorem. Okay, if you have only one side, but you know it's a 30, 60, 90 or a 45, 45, 90, you can use one of those methods. So trigonometry is for all the other examples. When it's a right triangle, you only have one side length and it's not a special right. All right, also just finding angle measures, you always use trig for. So trigonometry has a special acronym that goes with it. It's called SOHCAHTOA. We have three trig functions, sine, cosine, and tangent, and they can be found on your calculator, not sin, cos, and tan, as most people like to think. All right, and the SOHCAHTOA is an easy acronym to help us remember everything. So this S stands for our sine, and the sine function deals with the opposite side and the hypotenuse. Cosine is the next one, and that works with the adjacent side, meaning next to, and the hypotenuse. And then tangent is our last one, and that focuses on the opposite side and the adjacent side. Okay, now we'll talk about what all of those mean. But as you can see up here, we have our three ratios. Sine is the length of the opposite side over the length of the hypotenuse. Cosine's the length of the adjacent side over the length of the hypotenuse, and tangent is the length of the opposite leg over the length of the adjacent. So what is super duper important is to realize that when you're doing trigonometry, there are two different angles you can be viewing it from. First of all, we never do it using the right angle. Not from there. It's always one of the other two. Okay, so what I tell my kids to do is draw themselves. Nice hair. All right, draw yourself at the angle that you are looking from. It makes it a lot easier to identify what leg is opposite and what leg is adjacent. Of course, the hypotenuse does not change no matter your perspective, whether you're talking angle A or angle B. In these examples, we're talking angle A. So from here, of course, C is my hypotenuse because that's across from the 90-degree angle. From angle A, my opposite is going to be this side, and my adjacent is the B. Oops, sorry, that's supposed to be an A. If I were looking from angle B, I'm going to draw myself. Yep, I have one eye. All right, from angle B, notice that my opposite and my adjacent change places. So that's why it is super important to remember which, that's an A, side you are looking from, okay? So right now we're talking from angle A. So the sine of angle A is going to be the opposite, which in this example is our little a, over the hypotenuse, which is C. The cosine of angle A is going to be the adjacent, which is our B, over the hypotenuse, which is labeled C. And we'll plug numbers in just a moment. And the tangent is going to be the opposite, which is A, over the adjacent, which is B. Okay, so let's talk numbers. So down below it says draw a line from each trig ratio in column A to its corresponding ratio in column B. So now we're doing from the B angle. So now we're going to look at my blue drawing. Remember, we said from here things change. The opposite is the B and the adjacent is the A. It's different than when I stood from the A angle. I'm looking from B, so my sine is going to be, sine is opposite over hypotenuse. Opposite is B, hypotenuse is C. So it's this one down here. The cosine is going to be my adjacent over my hypotenuse. Well, my adjacent is A, and my hypotenuse is C. And the tangent is opposite over hypotenuse, or I'm sorry, opposite over adjacent, which is B over A. Okay, so it's important to start by labeling your diagram so you know which side is your O, your H, and your A, your opposite, hypotenuse, and adjacent. It makes it so much easier. Okay. Can't even, sorry. Okay. Scroll. That's all right. So let's write actual ratios of numbers. So the question is saying, what are the sine, cosine, and tangent ratios for angle G, taking a look at this diagram? I'm just going to erase this so we have some more room. All right, I figured out the problem this dual page display thing was on. All fixed. Okay. Sorry. So now let's do it from this triangle over here. So we're saying from angle G. So draw yourself on angle G. That's my hair, not my hat. Okay. Circle the measure of the leg opposite G. So which one is opposite G? Well, it goes directly across from it. So this down here is my opposite. So that's going to be 15. Circle the measure of the hypotenuse. Hypotenuse is always directly across from the right angle. And it's also the longer side. All right, the measure of the leg adjacent. Adjacent is directly next to the angle you are looking from. So it is our 8. That's my A. So then the question says to me, write the trig ratio for each of them. So sine is opposite over hypotenuse. So we said the opposite was 15. The hypotenuse is 17. The cosine, ca, adjacent, which was 8. Hypotenuse is 17. And toa, SOHCAHTOA. The tangent is the opposite, which was 15. And I'm just getting these numbers from the diagram over the adjacent, which was 8. So those are my trig ratios, okay? And we can do stuff with this. We can find missing side lengths, and we can find missing angle measures, which we'll get to momentarily. All right, so the question says, do it on your own. So pause the video. I will pause it as well. Notice it is the same diagram, but we're looking from angle T, so go ahead and draw yourself at angle T and go from there. Pause the video, press play when you're done, and you can check the answers out. Pause. All right, go ahead. Notice my person's a cyclops. Okay, my sine is opposite over hypotenuse, 8 over 17. My cosine is adjacent over hypotenuse, 15 over 17. And my tangent is opposite over adjacent, 8 over 15. Notice in all my triangles, I'm drawing a person, so I know my point of view I'm looking from. And then I also label my O, A, and H. It just makes it easier to look at. All right, guys, now we're going to actually solve some problems. Woo woo. Okay, so the problem says find the value of W to the nearest tenth. Below is one student's solution. They said the cosine of 54 equals W over 17, etc., etc., and they got an answer, but they are wrong. And this says let's figure out why. So taking a look from my diagram, here's the measure of angle 54, this angle right here. So draw your person. Spiky hair, kind of. All right, so from there, what sides are we given? Well, the W is my opposite. The 17 is my hypotenuse. So I'm given opposite and hypotenuse. Which trig function deals with opposite and hypotenuse? It's our sine. So the problem that this student ran into is they used the wrong trig function. If you use the wrong trig function, you will get the wrong answer. So we should have used sine. An error, they used the wrong trig function. All right, this says find the value of W correctly. So we're going to find the sine of 54. Actually, we're going to find the sine of W is equal to the opposite over the hypotenuse. And we are going to plug in the numbers that we know and solve for the ones that we don't. Before we do that, if you are using a graphing calculator, please make sure that the mode is changed to degrees. So hit the mode button, and down in the third column, you will see the words radian and degree. You need to make sure that degree is highlighted. So if it's not, arrow over and hit enter. Okay, so I know W, the measure of the angle is 54. Okay, it's the measure of the angle I'm looking for. So if I'm trying to find a side length, guys, I have to have one side and one angle. So the sine of 54 is equal to the opposite, which is W. We don't know that one, over the hypotenuse, which is 17. Now, do not type in the sine of 54 yet. That's a degree symbol, okay? Because you can round improperly. You do not get to touch your calculator until the variable you are solving for is alone. So in order to do that, I'm going to multiply both sides by 17. So I get 17 times the sine of 54 is equal to W. Now that my W is alone, I can go ahead, type it into my calculator just as I have it written. And I get 13.7532889. And my directions tell me to round to the nearest tenth. So the 7 is in the 10th place, the 5 tells it to round up, so 13.8 is my W. Okay, so your answer can be off by a lot if you use the wrong trig function. All right, pause the video, try on your own. Find the W here. Draw the person from the angle you're looking from. Make sure you pick the right trig function and solve. Please pause. All right, the answer is 3.8. The cosine of 33, because that's what I'm finding, is equal to W over 4.5. W is the adjacent side, so that's what I'm looking for. And the 4.5 is the hypotenuse because it's directly across from the 90-degree angle. I don't know what the opposite is, and I don't care. So to solve, I multiply both sides by 4.5, and then I type it into my calculator, and I got 3.77, which rounded up to 3.8. Okay, so that's what we do to find a missing side. So let's talk about now how to find a missing angle, which I think is easier to do. So in this case, we have two sides, but notice the problem is not asking us to find a third side. It's saying find the measure of an angle. So draw yourself at whichever angle you're trying to find, which is Y. Ponytail. Okay, now decide which sides you have, just like before. So from here I have the opposite and I have the adjacent. Notice I do not have the hypotenuse. So which trig function deals with opposite and adjacent? It's TOA. I recommend you write that on top of all of your papers. SOHCAHTOA. Looking at it can help you. So the tangent of Y is equal to the opposite over the adjacent. The opposite is 100. The adjacent is 41. All right, now I need to get Y alone, so I'm going to divide by tangent, which, guys, essentially is taking the inverse of the tangent. So I am taking the inverse. That's what that -1 means, okay, because anything to the -1 power is 1 over it, so it's like 1 over tangent. I'm dividing by it, and I can just type that into my calculator. If you look at your calculator, if you have a graphing one, to get the tangent, the inverse of the tangent, it's in blue above the tangent button. So I'm going to hit second tan. So whenever I'm finding an angle measure, I'm going to hit second the trig function, versus if I'm finding a side, I'll just hit tangent or sine or cosine. But here I'm going to hit second tangent, and I'm just going to type in 100 divided by 41. And I get 67.706, and the problem says, oh, it doesn't tell me what to round to. All right, so I'll truncate it at 3 degrees. 67.706 degrees. So same thing with an angle, except this time it's actually easier. It's less work. I just have to remember I'm taking the inverse. Okay, when I divide by tangent, it's like 1 over tangent. It's tangent to the -1st power. It's the inverse. And type that on my calculator. All right, last question on here. Yep, last question on here. Pause the video. Try it on your own, and I will put the work up here. Go ahead and pause. All right, take a look at my answer. For my person, it's the opposite and the hypotenuse, which is my sine function. So the sine of x is equal to 6 over 10. I then took the inverse sine of 6 over 10. I got 36.869 degrees. If it does not tell me what to round to, I need to truncate, meaning cut it off after 3 decimal places. I'm not rounding. All right, we are all set. Adios.